Okay, thanks for coming back for lesson 2 here on this, or not lesson 2. On lesson 9.3, this is the second installment. We are going to now talk about when we're solving quadratic equations by graphing where you have a situation where you get two roots. Remember, a root is a solution to this equation when you make y equal to 0. All right, so this is the same as the x-intercepts of the graph of the function. We talked about this in the last lesson. So what we're looking for is how do we write these equations in that ax squared plus bx plus c form, and then how do we graph that? All right, so we're gonna follow a process here, and I'm gonna kind of scroll up as we go so I don't give everything away. So they're giving us this equation right here that I'm circling with my cursor, right? And it says solve the equation by graphing. All right, so this equation is already written in y equals, or is written in y equals ax squared plus bx plus c, except that we don't have a y present. So all you do is you represent this with the function that this is showing. All right, and you represent it and write it in standard form just like this. Just make y equals negative x squared minus 3x plus 18. So the goal is to get all this junk on one side, right? Get all the terms with the x's and everything on one side, set it equal to 0, and then where you see that 0, you substitute that with y. And then our solutions are going to be where y equals 0, but we have to have it written as a function so we can graph it. Because you're only going to have maximum of 2 points that are equal to 0, right? So what I'm going to do now is I've got this equation right here, y equals negative x squared minus 3x plus 18, and we are going to go over to Desmos, right? And you know how I love Desmos. So we have y is equal to negative x squared, was it minus 3x? I think it's minus 3x plus 18, and we'll go back to, yep, that's it. Y equals negative x squared minus 3x plus 18. Let's go over to Desmos. And you can see, looking at Desmos here, that this makes sense. It opens downward, right? My y-intercept is 18. We talked about that in the first lesson. So this looks right. There's my y-intercept, blah, blah. So I want to find the roots. And remember, the roots are where it crosses the x-axis. So it looks like I've got a root here, and what's great about Desmos is you can hover over it and it usually makes it into a point. So it looks like my roots are x is equal to negative 6, or the other solution is x is equal to 3. So I have two solutions for this because this crosses the graph in two different places. All right, so hopefully that makes a little sense. Let's look at another one. Solve this equation by graphing. So we've got x squared minus 4x equals negative 3, and we want to write that first in standard form. So let's do that. So I'm going to put on my equation editor here, and I'm going to go y is equal to, well, I'm going to have x squared, and then we've got that minus 4x, and then you notice how the negative 3 is over here. Well, if I'm going to move that onto the same side as these terms, I'm going to have to add 3 to both sides. So that's going to be plus 3. That would make this side equal to 0 then, and that's where you put in your y. So you're just rewriting it so that all this stuff is on one side, make it equal to 0, and then where you have the 0, you substitute in your y, and that's making your equation into a function. And then once we have this as a function, we can now use this and plug this into, you can plug it into a graphing calculator, you can plug it into Desmos, or you can graph it by hand and kind of do it, but I think Desmos is a lot more accurate. So y equals x squared, and then I already forgot it. All right, minus 4x plus 3. All right, minus 4x plus 3. All right, and once we do that, you should see that your y-intercept should be 3 when you make these two 0, right? And it is. Your vertex is right down here, right? Your axis of symmetry is your x equals 2, which makes sense because you have negative 4 over negative 2a, which is negative 2 times 1, which is negative 2. So negative 4 over negative 2 is x equals 2. So there you go. And then these points right here, and I'll zoom in on them a little bit, right? These points right here are, you know, your roots, because that's where it crosses the x-axis. And you've got the point 1 and then the point 3. So 1 and 3. And later on, you're going to kind of find a much faster way to do the ones that have the neat answers. But we need to be able to visualize this and see what this means when you're talking about roots. So the roots are where it's rooted to your x-axis, if you want to think about it that way. All right. Thanks for watching. The next video is going to be on situations that have one solution. And before we go into that, I want you to just think about what that might look like. How can it have just one solution?